No. Okay. So welcome to the second session of the first day. Pertaining to this would be an interactive session and explaining about the uh, and its configuration, and the demonstration will also be given to you that how this cloud computing environment can be created and can be how that can be simulated. So pertaining stated clearly by the Professor V.C. Rao pertaining to this cloud. So mainly the main concern pertaining to this cloud is that how we define this cloud computing technology, how that has been used. So as you know that there are the various type of the machines nowadays that multiple virtual machines can be installed and can be used in the hypervisors or the and in that number of the world machines can be created to use the resources in a shareable mode. So in that case, if this computer upon which I am making this presentation is having a quad core architecture with that 16 GB of the memory and the 50 GB or the 100 GB 1 TB of the hard disk drive. So in that case, I can configure multiple number of the virtual machine as a or two core 4 MB or 4 GB or 68 GB of the memory space with the 50 GB available for the so that the multiple programs can run on simplified way of that generalized scenario which can be created in the system. The scenario that would require that resource to be available so to the applications, and that application need to be available with that virtual machine that and that has to be created with that configuration to use that further to know about for ARP. If you go amnitarp.org, it will show that the local it is located in somewhere in the California, some data center. So this robust in order to make the more availability and usability of the resource, in order to make availability of the near near to approach in a simplified way, we do require to have some sort of the environment. Pertaining to that, another way of instead of procuring those type of the equipment and making such type of the environment and testing them, that is a very difficult one. Like that, environments can be used as a part of the research of making them either in the hypervisors or the virtual machine environment using the VMware, we can make such type of the environment very easily. Now, pertaining to this, the challenges are there, as mentioned earlier during the morning discussion, that the challenges are there that how do we require to make this type of the cloud environment and available to the user. So pertaining to that, this IPA services, which is infrastructure, the platform and the software, a fragmented part of that is also been there. In that, we require to have that partial type of that resource environment, partial type of that so programming function part that need to be accessed, and the software so a localized or that a public type of the services infrastructure, if it is been available, that can be combined together so to provide services. Now, uh, in order to get the apply their application and their time they record their challenges are there so that the file is not getting uploaded or the system is overloading and the resources are not available. The challenges are based on that the system itself, the connectivity of using which that the connection has to be put together, whether that the pages that are dynamic or static and that need to be located at the different location. So the challenges are there for the challenges pertaining to we create a similar type of those scenarios in a simulating environment and analyze them to see that how such type of the system would work. Pertaining to that, the demonstration shall be given today in this very program. So as you can see over here that the part of this while using such type of the cloud system environment is that I requires to have the minimal resources at me. I need not require to bother about where that program, that system is located, who is monitoring, who is controlling, how much power to how to maintain that, and how and I need only a connectivity, better connectivity to connect with, and the rest of the things that need to be handled by the network operating center, and that should provide me all those type of the resources pertaining to the task and need that I require. So in that are there. So we have collected these slides from ISC Bangalore, Professor Yogesh, and this is a good presentation so which we are sharing with you. So in that case, the affordability is that in terms of the price, availability is that having a large data center available where that constraint pertaining to the resources should not be there, and in that case the security pertaining to that the task which I am using that I need not require to bother, that has to be handled properly, and whatever the task that has been given or submitted, in that case the result should be available to me in the time, and that is what is desirable, expectable, and that has to be intended to be used. So pertaining to that, only I requires to pay for that, and the things would be much simplified. So likewise, almost all of the industry and the academia for keeping their student records, industry to keeping the record of their client and their services, they are taking the use of the cloud computing environment. So in that, the the virtualization implies that we require to have a resources available hardware which is at the data center or that the warehouse where that the parallelizations and the virtual multiple number of the virtual machines which may uh, switch from the one system to the another system so without intimating the user, and that need not require us to bother about that, and that allows this flexibility to make that system available at the different location. So pertaining to that, the challenges have become much ease while using this the VMware and the HPC virtualizing software, which are to be mounted on the high-speed computing server systems, where the grid or the entire series of that parallel machines are mounted and that are operated using the software. So in that case, as you can see this, that this virtualization is required at the various level of the abstractions. So in a physical machine, we require to have the hardware resources and its operating system. So operating system may be of the varying in type and the applications based on that, whether that is compatible with that operating system that has to be mounted on that, and using that you can operate. So in that case, I may be using a single machine, or I may be using the multiple number of the machine. So in that case, the operating system may be different, and their memory and architectures are required for that. That has to be shared from the hardware available resources, as I just mentioned, with this example of the current computer system using which I am presenting this presentation. And in that case, it could be of the native machine, it could be of the hosted machine, and it could be in that 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 distributed architecture machine, which is located at the different locations, and many such type of that virtual machine which are connected together. So irrespective of the type of the operating system. So in that case, the Zen system, Zen server system, or the virtual machine, or the hypervisors, so these are the controller or the monitor of the monitor system, or the part of that operating system which provides us type of the flexibility. So this is what is being referred to as a virtualization. So in that case, uh, as there could be the as there could be the multiple number of the virtualizations, where a multiple level of the abstractions pertaining to the use and need of requirement of the resources that can be there. So I may be having the multiple number of the machine. How many machines do I require? Which type of the operating system do I require? What type of the services or the applications do I require? Whether that system is compatible or not. If I do require to have the gaming services, if I do require to have this deep learning services, if the GPU is not there, in that case, the time would be more, and that is system would not be handled those type of that exhaustive computations that need to be performed. So likewise, it is the task of that the network operating center and the monitor and the control systems to provide those type of the resources of software and the environment for that specific applications that can run over there. So constraints are there in of based on that availability of the resource, connectivity with that, and the speed of the operations that can be performed, and the applications, number of applications that you are running, and the size of the data upon which that application has to work. So in that case, the cost pertaining to this, which is also referred to as an amortized cost, that has to be used in order to analyze and use that, how much the total cost of that system would be if that has been taken for a day, a week, or a month, or the year basis. So in that case, it is up to that person or that organization how much amount that they can pay, and based on their application how much amount of the money they can charge to the end user. So if that is going on, in that case, the uh, two-third part that is being used in order to make such computations and resources availability and maintaining that, and one part of that that has to be taken as a part of the reserve that has to be used for the other uh, purposes by the organization who are providing such type of the services. So that will be considered that the $3 is that cost, total cost for maintaining. In that case, the $2 will be for updating the making all those changes using that application. So in that case, we can say that various type of that virtualization techniques are there, and multiple such type of that virtualization layer that can be considered. Based on that, the flexibility is available to make that possibility of availability of the multiple number of the calls, and based on that, the resources can be activated. The application based on that, which require those resources that would provide to run on that system, operating system, which is compatible with, and that will produce that output which will be provided to the end user. So this is what that complex scenario is there in this cloud computing environment to provide such type of the virtualization. So concerning to this is that how fast and efficient way we can do that. So in that, it is required that everything need to be performed at that cluster wherever that is been located. So the faster computation has to be at that not at the end user but at that server system, which has to be a vast series of the computer resources available and that are connected in the different architecture supporting that hypervisors and parallelization and the virtualizations and the multiple support, and that would enable us that faster execution. So this is what that expectation is, and but the main thing is that that will consume the lot of cost. So the cost is the concerning thing. So if I instead of procuring such type of the resources for the organization and maintaining them, that would consume a lot of manpower, lot of energy, lot of cost, that inheritance cost that would be there, and in order to make that maintaining that entire resources, that is very cumbersome. So I have visited some data centers and seen those type of the challenges that they do face. So the pertaining to that, one challenge is that in that single data center, majority of that services which were provided over there was for the banking systems and some organizations which are working in the financial services. So what was informed is that this is not a single virtualized center which is providing the services. The multiple such replica are there. One is at the Madras or that Chennai where we have visited. Other is at the Hyderabad and another at the Pune. So the multiple such type of the replica are there to provide that ease and convenience of the use of that infrastructure. Any update in that one system, so that is to be replicated to the another one, and the user need not require to bother about that they will, there is a change in that environment or the locations and the updations which is carried out in the data center. So as you can see over here that a vast series of such type of that parallelization and use of the computing system in the data centers are there, where that stackable architecture of this supercomputing environment is created with that all those layer of that optic cables are there which are connected with that ceiling and the ground, and that connectivity is provided. So in that seven levels of that protections that are there in order to keep this data center protected. So I just skip that part of that number of the layers and that protection levels, and you can see that the amount of the energy which is required to compute the parallel similar required to cool them. So in that case, the cost of that cooling is very much important. So nowadays, what is happening in that the glacier, the cold stream of that current which flows in the ocean, in that stream, the data center has been put into and that are placed and using that the additional cost of making them cool is not required. Or likewise, the similar ways that liquid nitrogen is to be flown at the different through silicon vias so to minimize the cooling power. So similar type of that you can see that the data centers which are there at the different locations where all those type of the resources are being used. Is it clear? Screen. Acha. Okay. So likewise, what I stated that multiple type of the scenario visualization. This is what I had stated, but vision data centers. It took us to the Cognizant data center, and there we have gone through the type of the resources which are being used. And interestingly, the majority of the people who were monitoring and controlling there were the female staff and accurately maintaining all those virtual machines which were being used. So any fault that I have seen that one that grid which or that entire array of that multi-core architecture so that was having the fault. So that hot swappable hard disks were removed and that entire card set was with that multiple chips that was replaced right, in my presence. So likewise, the such type of the environment where that the hot swappable architectures are there, so that while running the system, the fault is a part of that can be easily removed and that can be replaced with a new one. So likewise, this type of the flexibility has been provided. So various type of such type of the data center, whose data centers are there to provide such type of the services. So in that a majority of this such type of the servicing provider are the Amazon that is in Amazon warehouse where you have web services type of that which are available with the minimal cost. And the collab is also there where the certain part of that Google is freely providing so to explore you some machine learning techniques so that you may be able to comfortably learn about that. And if the data corpus is large and you require to have the larger resources to compute the task in a fast and efficient way, in that case you require to pay for that. So pertaining to that, as it is mentioned that entire set of the data or the fractional part of that that can also be taken as a part of the rent and you can configure them easily and in that the type of the services use of that are there and no, most commonly you can see that we are using the Gmail, we are using the Hotmail, we are using that Office 365, we are using this Adobe, we are using this different types of Dropbox, multiple such type of the software is a part of the services that Amazon or Microsoft Azure type of data service providers and the infrastructure and platform. So pertaining to that, the challenges are there that if certain load that increases, if that was going on, how much further load can well by the and efficient way I can go through that. So in that case, multiple such type of that level of abstractions where that management is required, and in that on that the charges are to be taken from the end user. As I give this example, the institute MNIT is giving the 50 lakh rupees for their ERP annual basis. So that is what that amount of the charges that they do take. But this is an academia with that minimal cost. If it is in organizations who is also providing or take hiring those type of the resources as a platform, IP, as I said, that infrastructure platform and software as a services. So in that case, the three time they have to charge in order to compete that and provide that services efficiently. So in between that intermediate servers or that system or the people who work upon them, which work as a broker, has to manage all these different managing of the resources and the services and update them and provide them to the user. So specifically in this that API files or that program files which are being created that are of the dynamic natures and may be used as per the need and requirement, and using that the virtualization can is been created, and in that the payment pertaining to that is to be there, and anything using which you require you have to pay for that. So as I said that initially if you want to establish, let us say $3 is to be paid for any record keeping. So once that record is created and that has been updated or that has been stored or the mounted in the system, initially that end user has to pay $3. And any updations and insertion or deletion of that would require the $2. Uh, so using that, that entire services of the system can be managed. So likewise, this is referred to as an amortized cost that need to be paid by the end user and required by the organizations to make that system easily available to the user. So many such type of the services are there where the multiple applications and the tasks which are available at the different nodes and the systems that can be combined together and provided to the user. So in that case, if the tasks are there which are multiple and the limited number of the resources are there using which only that part has to be computed, in that case that all these tasks are need to be queued and provided based on that different type of the scheduling techniques, and similar to that the scheduling task allocations and the optimization of the resources, that part shall be discussed in this the live simulating environment which you will go through. So in this, the client need not requires to see that the size of the resources and the amount of that computation that need to be done, and the where data files are being located, and how much that has to be kept as um, a retrieval data or that has to be done as a repository, and how much that need to be computed, and only it has to give that sort of this limited number of the command or the script. Based on that the task should be computed and that should be available. So in that case that the public IP or the infrastructure, so based on that that connectivity is to be provided, that must be robust. If this public IP or that service provider is having a bottleneck, and if the data center which is providing those type of the data is having the bottleneck of parallelization, like the InfiniBand, which is supposed to work at the 100 gig speed, and if instead of that, if I'm using a Ethernet 1 gig, so in that case that 1 is to 100 ratio is there. So in that case, I am compromising the resources, I'm compromising the speed, I'm compromising that computation, and using that limited number of the resources and the compromisation of the speed which is being provided by the IP service provider or that internet service provider. In that case, my bottleneck would be there. So to isolate or to remove this pertaining to that, the entire updated hardware at every level of the abstraction is required, and that would make that feasibility of the robust environment where that computation can be done. So assuming such type of that environment where those limitations are specified, the speed, their number of the resources available, number of the cloudlets, and the number of the virtual SIMs, if that are being initialized and that are initiated in the distributed computing architecture. So in that case, amount of the tasks which may be coming from the multiple number of the clients, this is the task of that controller to provide which resources should be used, and which how many number of the virtual machines are there, and how much the resources are available. So resources implies the memory, computation power, the space, and that the application programs using which that the system has to operate, and how much computation times that would compute, and how much the tasks that need to be performed. So having all those type of the scenario, then this is the task of that the network operating center or that controller of that virtual machine environment to decide that which machines would be the best suitable, where it is been located, and in what fashion that need to be assigned. It should not be overloaded. It should not be underloaded, and that all those resources which are been there, in that case it should not happen that some machine has never been used and the rest of the other one are being exhaustively used. So such type of the challenges are there. In order to mitigate that, simulation environment can be easily created, and virtualization of that can be simulated or the simulated based on that the strategy, the best type of the strategy available that can be tried, and we can say that having such type of the environment, our approach would be the best one. That is what the achievement is. So pertaining to that, you can see over here that this infrastructure can be there, which are differently located at the different locations. And here is the some example of that uh, that how this type of the infrastructure is used. So some of them are that application servers, some of them are that web services, some of them are some sort of that API program or the functional program which are specifically be designed, and pertaining to that the machines are located near to them and that can be used. So this is what that the system is in the networking environment. So pertaining to this, the challenges are there that the creation of the data center is a challenging one. There were the when I visited over there, that was the 20-year back time. So there were the 15 data centers in the Bangalore and the Chennai. Nowadays, that has been multifold such type of the data centers. So managing, providing such type of the services with that virtualized and better service environment, the parallelization and the multi-core architecture is very much important. That plays very much important while making such type of the environment. So the knowledge of the hardware, knowledge of the infrastructure, knowledge of the parallelization, knowledge of the interconnectivity, knowledge of the interfacing, knowledge of the internet connectivity, knowledge of that distributed computing environment, knowledge of providing that services with that distributed file systems, distributed applications, and using of the RPC version 3 and accessing that, and the use of this inter-process communication. All these are those important aspects that the is a part of the engineer who has to handle such type of the environment and need to handle that using such type of the resources. They must aware about all these things. So we can say that for a simplified way, the resources, a limited resources pertain to the certain applications, we can rent that, and the whatever that minimal cost that could be applicable, we can apply for that, and that resources will be available, and we can go through that. So in that case, it is an easy to use task without bothering about the making such type of that environment in house. Likewise, which we are doing in our institute. So normally in this, the challenges are there that how much that can be located and how much we require to pay for that. Now, having this global connectivity, having this uh, 12 parallel optic fiber line which are been there, which have going from that Bombay to other countries, to the through that Gulf and to the European, and then connected to the USA. All this, and where that majority of such type of that infrastructure is available in the USA, you can see that flexibility and the use of this multi-core architecture is very much important, and that parallelization and the multiple number of this optical cables line that are there, uh, a huge bunch of that line, that optic cables that are there. So pertaining to this, the cost of using is very important, that how do we require to estimate the cost. So in this, the it depends on the availability of the resources. So there is a fixed per capita income establishing that data center or that warehouse. Likewise, a small data center which we are in our institute, in that that is already that has been established. So the cost of that is already been done, and we have make that some available of the researcher, the faculty members, and how many, what type of that configurations that need to be used. In that case, that part of that would get skill pertaining to that availability of that resources. And you can see in the first A slide that the cost will get increased as per that number of the resources that would be used. So in that case, I need not require to bother about this fixed cost which has been incurred in order to establish such type of that cloud-based environment. So that entire this slashed line of that cost that will be cut, that will cut down, and only that cost pertaining to that the value that resource requirement and its cost of usage would be there. So in that case, if I use that extensively, that resources with that minimal number of the resource with that maximum output, if I would require to gain, in that case, my profit would be more. And that is what, and this profit should be of the multiple fold of that the charges which are being taken from the end user. So amortized cost would give me that assurance that my profit should be there while using that the resources which has been created by some other persons, by the applications either that we are being created by me or that are available, and I can use that and provide that to the user. In that, the cost of that would be there. So in that case, that if the number of user using that the applications are there more, in that case, the incurring cost of that would be more. So this is what that expectation is. And pertaining to that, there are the certain type of the challenges are there, which are part of that additional cost. One is that the speed of operations, the size of the clusters, the number of the resources, type of the services, whether you require the additional some sort of the quality of the services, and the period or the time upon which that resources are to be used. So in that case, all these 6, 7 points that are very much important, because in the night that energy is more available and the people are less using that resources. The speed of the network is high, the resources are less overloaded, and in that case the charges would be less, unlike that has been there in the morning scenario. So likewise, that challenges are there. So in that case, the variations are there in the command to be used, in the demand that to be used, and that is varying. in that 24-hour day time. So in that case, normally you might have seen that some of the company or organization, they have the three different intervals, 8-hour period of the time. So where they put all their manpowers and their work they have because their timing period is different from that other location where data services are to be provided. So, like the England and India is having the uh, uh, 4.5 hour time delay. Okay, so in that case, when it is here is the evening, there would be the afternoon or that the working period. So in that case, the shift has to be changed, and the staff would have to work on that very period, giving that they are working at the same time. So this is what I would have to state. The other part pertaining to this visualization and use of the uh, Madhav Khatri would give you that visualizations and the configuration environment that he will show. Madhav?
Sir. Yes, sir. Am I audible, sir?
So over to the Madhav. He will give you that presentation and that simulation environment of the cloud sim using the cloud sim. And we have applied multiple type of that multiple type of the algorithms for the load balancing techniques. And initially, how this the cloud simulation environment to provide us or give this flexibility to create the thousand number of the nodes or the lakh number of the nodes with the multiple number of the virtual machines and use of this virtual machine for the different type of the benchmarking task that need to be performed using these machines. So Madhav,
Yes, sir.
uh, uh, so start demonstrating that part
Yes,
of
sir.
the cloud sim.
Okay, sir. Sir, is screen is visible?
Yeah, yeah, it is visible.
Yes, sir. So this is the Cloud Sim simulator, and it's a Cloud Sim 3.03, and we are using Cloud Sim to simulate the environment. And because this is an open source framework for modeling and simulating cloud computing environments, and it is typically used to simulate cloud infrastructures, applications, and services in an virtualized environment. And why we use cloud sim, and because it's an free and open source, and for academic research without any licensing cost we can access the resources. And its scalability is very large because it is essential for to analyze large applications or services using cloud environment. So it is highly modular and for scheduling algorithms and configurations. So yes.
Just Madhav, I would like to emphasize that any simulator using which we require to test such type of this vast cloud-based networking environment where that challenges are there, as I mentioned, that the different resources is their scalability, availability, and the locations and the usage of them, of those type of the virtual machines based on the availability and the task which is already that resource and pertaining to that the challenges are there. And the initial part of this presentation would be that you would be able to see that the different type of the instructions and the steps that need to be followed, and what are those information that triggering part where that the number of the cloudlets and the number of the virtual machines on that very cloudlet that has to be used, and how much how that are being connected, assuming that that the plane or that environment which is been created using this is having that uniformity of the same bandwidth. So if the variations are to be made, in that case, how that can be done, and if the imbalance in the network is there, in that case, how the our algorithms or the approach that need to be applied in order to balance that networking environment or cloud-based networking environment. So over to you, Madhav.
Yes, sir. So good evening to all of you, and we are using an cloud sim simulator to simulate the environments for to use this virtual environment, because there is a lot of sim features in cloud sim 3. Because we are using a 3.0, it's an old version, and but the infrastructure for the infrastructure purposes and virtual machine and resource allocation, this is very important tool. And
Madhav,
yes sir.
Madhav, could you
Yes.
increase the size?
Yes sir.
The participants are requesting that the font size should be increased so
Okay,
that
okay.
they can see, or you can visualize that in the full screen.
Okay sir. Okay sir. Is now it is visible?
Still, it requires to be in the large screen, full screen.
Okay, okay
Can you
sir.
make
Sir,
that?
yes sir. Give me a minute, sir. Give me a minute.
I think it is now. Agam is saying that it is now visible.
Yes sir.
Control plus, huh? Control plus will increase the font size.
Yes sir. The text is visible, sir, because the tool is because it is not like we are not using Visual Studio. Here we can use, but it is in the simulator. The size is maximum at this, because it is, we are using
Ah,
Eclipse.
ah. So
Eclipse in Eclipse,
what
this
I suggest the participant that there is a one there's a plus and minus sign over there. So you can increase the font size, that plus just I had done screen size, increase the screen size 125%. So now I am able to visualize this. So you can increase the size, screen size. And anyway, the part of this can be, means all this source,
is now
the
it is visible,
simulating
sir.
environment that shall be shared. Yeah, please continue.
Yes, sir. This is our code. In this, this is an example to where we are using one user and uh, uh, one virtual machine. So we are creating the virtual machines and its attributes. So according to that code, now we are creating the cloudlet list. So in the first method, we use cloudlet list to store the cloudlets in the environment, because cloudlets are the tasks which are assigned to the virtual machines, because if we cannot directly provide the task to the cloud, uh, we have to uh, we have to separate the task in cloudlets, and in the form of cloudlets we are providing the task to the virtual machines. So here we required a data center broker in the middle of that. So first step is initialize the cloud sim package. Okay, so in this we are initializing the user. Here we are taking one user for the one cloud. Okay, means we are for the multiple purpose cloud we can extend the list. And but here now for to understand this example, we are taking one user at a time, and then after this we are creating a flag. It means a trace to even whenever a cloud is assigned to the user, the task will be initiated, and that task will be given to the data center broker, and the data center broker will assign that task to the virtual machines. So here now we initialize the CloudSIM library. uh, After initializing the CloudSIM library, we are going to the next step, which is create a data centers. So now the data centers are created because we know the data centers will hold the task and that task will be assigned to the virtual machines. So for that, we create an instance of the data center. So it's an data center object. Here we create an instance of data center. Now we come to the third step. We create the brokers because we can directly assign the task to the virtual machines. Here we require some data center broker that can take the task from the user and then assign it virtually to the virtual machines, because we can't directly there are some problems with the virtual machines, because virtual machine can't handle a large amount of tasks. So we assign the chunks of tasks to the virtual machine. Now we come to the fourth step, where we create a virtual machine. Here we create an array list where virtual machines is assigned, and the attributes of the virtual machine are given in the description. So these are the attributes we assign to the virtual machine, where we take an ID of the virtual machine, because a unique ID is assigned to a unique virtual machine, and each virtual machine has its own ID. And second attribute is MIPS, which is the speed of the execution. Means we can't directly execute the task with, by using virtual machine. We have to check at which amount of how these tasks are assigned to virtual machines and how these tasks are executing on the machine, because the speed is calculated using MIPS unit. After that, the size of the packet is assigned. Means the size of the packet is 1000 MB. Here we have initialized these attributes. You can change these attributes according to your need. So after we have decided the RAM value in MB, which is 512, you can increase the RAM value according to the attributes of the virtual machine. So we have managed these tasks. Now bandwidth is assigned. After that, we have taken two new attributes here, network latency and security, to enhance the features of CloudSIM environment. It is not given in the CloudSIM. We have added these two values new in the CloudSIM environment to enhance the features of the CloudSIM simulator. Now this is the number of CPUs are assigned, and we have given the name of virtual machine is Zen. Now we create the virtual machines VM, and after assigning the task, we have to add this VM to the VM list. Okay, so this is the main important thing. Means we have to assign the VM list to the virtual machine. After this, we have to submit these VM list to the broker. Means at the last, the broker will collect all the virtual machine list, and it will be assigned to the user. Means the user will can't directly send the task to the virtual machine. It will make cloudlets, and then cloudlets are assigned to the data center broker, and then data center broker will send the task to the virtual machines. Now the fifth now come to the fifth step, which is create one cloudlet. Means we have to create, every time we have to create a cloudlet. So for that, we have assigned the properties of the cloudlet. Here id is 0. It means for a unique cloudlet, we have to assign the id, because every time the cloudlet comes to the virtual machine, it has its own id, own length and file size. So we have taken these values are already initiated in the CloudSIM simulator. We don't have to change these values, but according to your own needs, you can change these values and see the results are variation. And after that, we have to add the cloudlet to the list, because the cloudlets are created. Now these cloudlets are added to the list, and after that we have to submit that cloudlet to the broker, because broker is the mediator between data center broker and the cloudlet. Because cloudlets can't directly assign to the data center, we have assigned data center broker to collect the cloudlets and assigned it to the data center. Now we have to start this simulation. After the simulation is started, we can calculate how much time is required to execute one cloudlet. Means the maximum amount of speed will be calculated in MIPS, which is directly assigned in the simulator. But we can change these tasks according to your own need. Now, come to the create data center part. Now here we have to create the power data centers, which can create a list to store the virtual machines. Means here the host lists are created, and these host lists are assigned to the virtual machines. So a machine contains one or more CPU cores. So in this example, we have created a array list, and in that array list, we have collected the host list. The number of host, if the number of host increases, the MIPS value is also increased. So here we have to create a PE and add these to the list. So need to store PE ID and MIPS rating. So for this, we have created an array list, and in that array list, we have assigned these CPUs, and after that, we have to add these lists to the user. Now create host with its ID and list of keys and add them to the list of machines. So in this, these are the attributes only. You don't have to change every time the host ID, because it is in the simulator, by default, it has taken the value 0. Now come to the fifth part. So this is our machine. Now these are the attributes of the virtual machines. Here the name of the virtual machine is Zen, OS name is Linux, and the architecture is 8086 means system architecture is 8086, means it's only an attributes. You can change these attributes according to your own need, but the simulator will by default take these values. Now come to the time zones and the cost of the processing unit. Means every time the cost will be changing. When the user collect the task from the machine and then provide the cloudlets to the data center broker, the data center broker provide these tasks to the virtual machine, and then virtual machine starts their execution. If there are multiple virtual machines, they will take their own time to execute the task. Now, so we have to create the power data centers. For that, we have initiated the task, and then we provided it to the data center broker, and then data center came. Here the value of the data center will be null, because these are the power data centers. Power data centers are the core of the machines. Now here, now we have created the data center broker. Okay, so this is the mediator between data center and the cloudlets. Now come to the print. This is the last part of this example. Here we have printed all the things. Means how much time is required by the cloudlet for the execution, the starting time, from the starting time to the finishing time we have to calculate. Now I have to run this code. Okay, so when I run this code, now this is the output. Now you can see, yes, you can see the status is success. The data center ID is 2, because we are taking one user at a time. In this example, we are taking one user at a time. So it is showing that the status is success. Data center ID is 2 and virtual machine ID is 0, and it is taking around 400 milliseconds. 400. It is in 400 milliseconds to execute a one task. Okay, so now this is the output of our first example. Okay, are you getting? Am I audible?
Yes, sir. Yes, sir. You are audible.
Okay, now we move to the next example. So now this is the second example. Here now we in the previous example we have taken one user at a time, and one virtual machine is there. Now here come to the second example. So in this example, we are multiplying the virtual machine. Means what we want to understand, we want to understand if virtual machines is multiplied by 2. Okay, so what will be the result after multiplying the virtual machines? Means we can increase the number of virtual machines according to our environment, because in this we have simulated the virtual environment according to understand this how cloud sim is executing at the task. Okay, So now this is my second example. Now, okay, so in this we have the same thing is here. We have created the virtual machines. Okay, we have assigned the list to the data center broker. Now, in the third part, we have created the VM list and a VM description is given. Now here we have created two VMs. So you here two VMs are created. In the previous example, we have created only one VM. Now we have created two VMs. So for this, we have initiated two objects, VM1 and VM2. Now we want to add these two VMs to the list. So for that, we have added these VMs to the VM list. After that, we have submitted the VM list to the broker. Now the fifth step, come to the fifth step, we have created two clouds here. Now for these clouds, because there are two tasks, I'm assuming there are two tasks, and these two tasks are assigned to the two virtual machines. So for that, we have created the cloudlet properties. Here ID is 0. The same thing is here, because in the last example we have initiated the cloudlets using their properties. Here the same thing is here, but the cloud number of cloudlet has changed. Now for two cloudlets we have used two different objects, cloudlet 1 and cloudlet 2. So for cloudlet 1, their ID, length, core CPU number, file size, output size, utilization model, and for because this is a cloudlet one object, so for that object we have different attributes for the cloudlet one. Similarly, for the cloudlet two, we have the same attributes, but the values are different, because both the cloudlets are different. Cloudlet means the task which we are assigning to the clouds. Okay, now come to the cloudlet list. Here we have created two cloudlet lists. For the cloudlet 1, cloudlet list is created, and for the cloudlet 2, cloudlet 2 list is created, because every time a new task is coming, it will be assigned to cloudlet 1 or cloudlet 2 according to the program. Now submit cloudlet to the broker, because cloudlet is created. Now we have to submit this cloudlet to the broker. Now bind the cloudlets to the VM. Now we have to bind the cloudlets to the VM. Means every time a cloudlet is coming, we have to bind this cloudlet. Bind means we are assigning this task to the virtual machines. Now come to the sixth step. Cloudlet simulation is started. Now in this, we have to calculate how much time is required by the cloudlet to execute on the virtual machines. So in the final step, we have to print the results in the simulation. Now after that, we have to finish this code. For that we have created a data center. In the data center, we have assigned the host list. This host list is created in the starting of the program, because every time the new data center, the cloudlet is assigned to the data center, and it will be checked like which cloudlet is assigned to which data center. For that, we have created a list of machines. Now coming to the P's and add these to the list. P's means the CPUs and the cores, because in the virtual machine there may be multiple cores, or quad. It will be quad, it will be octa. According to the properties of virtual machines, we can assign these values to the program. Now the host with its ID and the list of virtual machines added list means these are the attributes only. We are assigning these attributes to the virtual machines. Now come to the fifth point, create a data center characteristics. So it is important thing, because every time the virtual machine may be different. So we have this is the default values of the virtual machine in the CloudSIM environment. You can change these values according to the properties of the virtual machine. Now finally we need to create a power data center object. Here we have created data center object. Now come to because we can change the policies, because this is a resource allocation program, so we can change these properties for here in the further versions of CloudSIM. You can check CloudSIM 7th version is also came, and in that version there are some properties and policies have been followed, in which the resource allocation schemes is different. So for that, this code is required. Private static data center broker. Data center broker is the intermediate between cloudlets and data center. Now coming to the last part, which is the print statements. Here we are printing the values like actual CPU time and the starting execution time of the cloudlet and the finish time of the cloudlet. So both these times are compared. Means how much time is required to execute one task at a particular virtual machine. So according to that, we have simulated the environment. Now I have to execute this code. See, this is my result. In this, uh, I have taken two cloudlets and two virtual machines. So both are successfully assigned to the virtual machine, and only 1000 milliseconds is required to execute a particular task. You can see 1000 milliseconds is required to execute a particular task, which is very minute. But in the milliseconds, the task is executed. Okay. Now coming to the third example. Here I am changing the scenario of the simulator. Every time I am changing the scenario of the simulator. Uh, am I audible? Am I audible?
Yes, sir. Yes, sir. You are audible.
If anyone has any question, you can ask because the screen is not visible. The chat box is not visible to me. So you can ask me any question. Yes.
People can ask their question in chat box. We will convey the message.
Yes. Can I proceed?
Yes, sir. No question as of now.
Okay. So now I'm coming to the third example. And because first example there is only one cloudlet, in the second example two cloudlets are there and two virtual machines are there. Okay, now I'm coming to the third example. So in this example we are creating a new simulation environment. Okay, in this the number of user is same. Means in the initial part we are taking a number of one user at a time, because we don't want to complex this environment. First we have to understand the basics of the cloud SIEM, which is very much required when you try to scale the environment, because the one of the key feature of the cloud SIEM is scalability. When you drive the properties of the cloud SIEM, here scalability is one of its key features. Okay, so we are proceeding according to the features of the cloud SIEM. Now the same thing is in the cloud SIEM example 3. The same thing is here. We have to initialize the package. Okay, means the initial number of users are taken equals to 1. The same trace flag is there. Now the cloud SIEM environment is initiated, which is number of users, calendar, and trace flag. These are the attributes. So cloud SIEM will take them by default. Now the data center is created. This is an instance of the data center. It is not a full data center. We are just creating an instance of the data center. Now we assign the properties of the data center to the data center characteristics. Okay. So before this, I would like to explain this environment in a broad manner, because there are some of the other sources also. Because this is not the only part. Here you can see this is cloudlet.java file. Okay, in the cloud SIEM environment, every time you have to change this file when a new function is arrived. Okay, because I have changed this whole simulation environment, and here you can see we have changed these functions also. Okay, set size, get size, set bandwidth, get bandwidth. According to that, you can take new functions in the cloud SIEM environment. Okay, so here we have changed these files, and because this is new file I have created for the list, because least required time is because somehow in the array list, which program will take a least time. For that I have created this file, and there are many more examples, like for max min scheduler we have taken this file for the max min scheduler, because every time a scheduler you can change the resource allocation scheme. Okay, this is the property of the cloud SIEM. So we have created a max min scheduler here. Similarly, we have changed the network topology here. You can change the topology of the network here. Okay, means the topologies may be different. You can design your own topology and change in this environment. Okay, and now I'm coming to the third example again. Yes. So now we have created the data center instance, and the third step is we have to create the broker. So for that we have used a data center broker, and the data center broker will provide the task to the virtual machines. So for our fourth step is create one virtual machine. In this environment, we have created one virtual machine. VM list equals to new array list. Now VM description is given because the virtual machine requires some properties. So here we have assigned these properties to the virtual machines. Now here one logic is came because in this cloud sim environment a random number is not there. Now we take random number because we have assigned these two. These two values are not given in the cloud sim 3.03 environment. I have changed these 3.03 environment, and we have added these two network latency and security to enhance the features of the cloud sim 3.03. Means that simulator which you downloaded and the simulator I am showing to you is different because these values are not written in the default cloud sim environment. Okay, so we have written this code, and, because every time you have to change the network latency, and for the security purpose we have taken a new attribute security here, and because why we have taken random number here to enhance the features of the clouds. Every time we have to check the result, every time we have to compare the results with the previous algorithms. So we have taken random numbers. You can remove this part, because this is our code, and we have enhanced this feature by using this code. Okay, this is not a default cloud sim code, it's an enhanced cloud sim 3.03 environment. So we have written this code. Now coming to the added VM list. So there are two virtual machines. So for two virtual machines, we have taken VM1 and VM2. Okay. Now coming to the fifth step, we have to create two cloudlets. You can change the number of cloudlets. In the these programs, according to the variations of the cloud sim, we have changed it. Now coming to the cloudlet properties. So ID, length, file size, these are the properties of the cloud, and the utilization model is given. So cloudlet 1 and cloudlet 2, both these cloudlets have assigned their properties, and then these cloudlets are added to the list. Now after that we have to submit the cloudlet, and then we have to run the simulation. Okay, now see this part. Okay, the other things are same, but when we run this code, you have to see this. Now see this output. Here the variation is different. For the cloudlet one, 80 milliseconds are required, and for the cloudlet 2, 160 milliseconds are required. Why? Because there is variation in both these tasks, because we have changed these values. Okay, we have changed. Because we have changed this value, the results are different. I'm again executing this task. Now see, there is a variation in these tasks. 80 milliseconds for the cloudlet 1 and 160 milliseconds for the cloudlet 2. Okay, and you can check the initialization properties here. The broker is assigned the cloudlets. Now the broker will send these cloudlets to the data center. Now these data centers will send the task to the virtual machines here. So every time, whenever a cloud has not assigned any virtual machine, it is showing destroying VM0. Means in the after completing the simulation environment, the VM will leave the environment, and the virtual machine will be destroyed, because we are not taking the virtual machine every time in the memory. We have to destroy the virtual machines after executing the task. So this is the property of the cloud sim. Now coming to the example number 4. So if you have any doubt, you can ask me, and because I'm going in according to the properties, I'm going to understand how this cloudlets are assigning to the virtual machines, and the environment we are understanding to enhance the features of the cloud. Okay. So every time I am changing the schemes. So if you have any doubt, you can ask. Now coming to the example number 4, here the same thing is here, but we have taken two values. Here the number of users are same, everything is same, but the cloud sim properties are different. Here you can see the data centers. We have taken two data centers here. Now in the previous example, we have taken two virtual machines and two cloudlets. Now in this example, we are dividing the data centers. Means we are not taking one data center at a one time. We are taking multiple data centers. So data center 0 will take the task from the cloud and assign these tasks to the virtual machine. So we are going in an hybrid environment, and we are scaling the environment according to our needs. Okay. Now coming to the third step, data center broker is created and the ID is assigned to the data center broker. In the fourth step, VM list is created and the VM description is given. So every time when we are using new virtual machine, we have to give its ID, MIP, size, and RAM and bandwidth. You can change these values according to the virtual machine properties. Now this is the different thing, because we have changed these examples. These are not the default examples of the cloud sim. We have changed these examples according to the hybrid cloud, because this is these simulation environment is different. Okay, so we have taken network latency and security, and P's numbers are changed, means the core numbers are changed. Now coming to the two virtual machines here, because here two data center are created, and for the two data centers we are taking two virtual machines. So every time we are enhancing the features of the cloud. Now we have to add these VM to the VM list and submit these VM list to the broker. Now coming to the fifth step, we are creating two cloudlets, and each cloudlet will be assigned to a new task, new virtual machine. So now coming to the cloudlet properties, these are the cloudlet properties. You can change these cloudlet properties according to the environment, because we have used an hybrid environment. So these values can be changed. Means according to the need, you can change these values. If I change this value to the 1 lakh, it will change the result value. Now coming to the cloudlet 1 and cloudlet 2. Both these cloudlets have assigned some attributes, and these attributes have different values, because these two cloudlets are showing that tasks are coming from the user to the cloud, but these tasks are not coming directly. They are divided into the cloudlets, and these cloudlets will be assigned to the data center broker. Okay, now coming to the next step, which is, now the broker has created. Now we have to start the simulation. Now I have to run this code. Now see, the data center ID is 2 and cloudlet ID is 0, means this output is showing that cloudlet ID 0 is assigned to the data center 2 with VM ID 0, and the starting time of the cloud sim is 160 milliseconds. Okay, and the finish time, see the variation 160.2. So it's very means very minute time to execute the task, because we are dividing the data center into two parts, data center 1 and data center 2. So this will distribute the task, and see, if we have task 1 and number of virtual machines are 3, and so the task 1 will be divided to the 3 virtual machines. Okay, it will distribute the task to the 3 different virtual machines. So here we are taking 2 data centers and 2 virtual machines. Now the virtual machine will divide the task according to the data center. So here see the variations is very minute. Okay, now coming to the fifth example. Okay, now coming to the fifth example. Now here I have taken the cloudlet list and VM list. Okay, so these are the means initial variables. We have to initialize the variables, cloudlets and VM list. Now coming to the fifth example. Now here we change the number of users. In the previous example, the number of user is 1, data center value is 2, and the two virtual machine is there. Means we are scaling the environment according to our needs. Means if cloud is simulated on the virtual environment, it is easy for us to see how it will change the results. So here on the simulator, we can change according to our needs and see if there is any variation. Now, the calendar and trace flag, both these variables are initialized. Now to the CloudSim library, you can see the CloudSim library is there. We have initiate CloudSim library. See, I'm going to CloudSim cloudlet scheduler.java. Now these are the files. See, these are the files we have changed here because these are not the same file. We have changed the VM machine. Now see, I have taken two variables here. So I have changed the vm.java file here. Now I have changed. Now here you have to take different variables. Like here I have taken, because I have taken two different values, so for that I have added two attributes in the VM environment. Okay, now the whole code is changed here. This is not the previous simulator, because in the previous simulator different methods are there. In my new simulator the totally environment is changed. Okay, now this is an allocation policy, because every time you have to allocate the virtual machine to the task, the allocation scheme is different. Okay, so we have changed these examples. VM scheduler, for the VM scheduler part, I have changed this code. So this is the cloudlet properties only. There are so many files here. You have to change according to that. So for the distribution, you have to change these files. For the cloudlet list, you have to change this file, VM list, because I have taken this different VM list. So I have changed this code. Now, for the graph reader, for the topological graph, we have changed the topology here. For the power, we have changed these files are changed according to the needs, how you have to simulate the environment. Okay, now coming to the previous example again, CloudSim example number 5. Now here we have taken two users and two virtual machines. Okay, so these virtual machines are different environment, because we have changed the allocation policy here. We have changed the VM properties here. Now these VM lists are added to the VM1 and VM2. Both these lists are different. Means every time a new VMS came, it will be added to either VM1 or VM2. Okay, so it is, and this part is added by us to increase the efficiency of the simulator. Okay. Now coming to the fifth step, which is creating the cloud list. It is same as we are dividing the task into smaller packets like that. Okay, but now this the scheme, resource allocation scheme is different, because the algorithm is different. Now see here, we have assigned the cloudlet list to the broker, and every time the broker has assigned the cloudlet list, it will be assigned to the cloud. Now the after now I have to run this code and check. Now see this, both these tasks are different. Means for the user code, a cloudlet 0 is provided. Means this is an ID. This is an ID, cloudlet 0. It's an ID of the cloudlet, and it's an data center ID. So every time you can see the variation. Very small variation is there. Very small variation is there. 116.1 milliseconds and 160.2 milliseconds. Means two different users are assigned two different tasks, and there are two virtual machines. So we are seeing, is there any variation between two, because user 4 is able to execute its task fast than user 2, user 5. So there is very little variation in this. So it will not be counted like 0.1 and 0.2. According to the start time, it is varying. Means there is no any execution difference between both these tasks. Both are running equally, but there is the start time of the task is different. Okay, now coming to the example 6. So in the example 6, now here, now we have changed the VM parameters here, and the same thing is here. We have changed the whole code. Now this code is already changed. because here now we have used different methods to assign attributes to the virtual machine. I have used for loop to assign different values to the virtual machine, because every time you cannot use a for loop. Here we have used to enhance the feature of the code, to optimize the code. We have used this. Now coming to the create cloudlet part, we have because the list of cloudlet is created and the cloudlet parameters are assigned. After that, the same thing here. These are the static methods. Okay, whenever we call this, the try function will be executed first. Now same here, the number of users are 1, and after that, in the second step, data centers are created. So two data centers are there, data center 0 and data center 1. These are only in objects. This is not a real data center. Real data center will come in the file data center characteristics. Now this is the real data center. See, this is a very large code, very large program. It's not easy to change the all the files, because there are around 300 to 200 files are there in the whole. If you change each one code, it will require a lot of time to understand this. So in the short, I will directly execute this cloud sim example 6. Now see this part here. Here in the comment section, I have changed this code. This is the by default code of the cloud sim. So we have changed this code. The allocation scheme is changed and the virtual machine properties are changed. And after that, data center is created. And then we strongly encourage to develop their own broker policies, because this is an open and free source. Okay, you can make your own algorithms and run on this cloud sim, because there are so many features in the cloud sim. This is not only a simulator. You can use iCan cloud sim, you can use grid sim, you can use net sim. There are so many cloud environments are there, but to in the whole of the properties, like scalability, like cost, because this is a free open source software. You can use it on your own desktop, complete the environment. Okay, you can change the environment and allocation policies are there. And there are so many properties you can because you can use it on in a very because it will change your entire perception around how this simulator is working. Okay, now coming to the uh, print cloudly, it's the last task. We can directly run this example. We can directly now see this task. So how there are so many tasks are there, it can directly be allotted to the data center broker. Now see execution time. Now see there is no any variation, no any variations. All the cloudlets are executed at 332.87 milliseconds, which is very minute, because there are no it will execute the task in a very minute time. Okay, the whole code will be executed in a very minute time, in milliseconds, and there is no any variations, because all the tasks will directly go to the virtual machine, and the virtual machine will execute the task and print the results directly on the simulator. You can change this according to the IaaS function, which is infrastructure as a cloud. In the America, it's already been told that there is very much it is very costly to develop the infrastructure for the cloud in a very large environment. So we use simulators to just see how these infrastructure will be developed. If we want to scale the cloud environment, and because it is very costly, so we develop this environment on the for the practical purpose. We can develop this environment on the simulators. It's very easy for us. Okay. Now coming to the example number 7. See, now in the example number 7, the same thing is here. The number of users you can take 2 to 3 users are there. See, the number of grid users are 2. Okay, now same here, we have to make a data centers, data center 0 and data center 1. After that, the broker is created and the broker will assign the task the cloud sync. Now see here, a thread that will create a new broker at 200 clock time. Means every time a new task is come, the broker will take some time to see if this is a new task coming to the environment, or the task is already been assigned to the virtual machine. So for that, we have used a comparison environment here. Now in the comparison, see, every time cloud cloud, a new user enters into the environment, it will surely ask cloud to get some new files here, because the cloud, in the cloud, multiple users can came, and multiple users can access the cloud at the same time. Okay, so maybe your cloud will the complexity of the environment will increase. So for that we are changing the environment according to the variation. Now coming to this, uh, new thread has come, because every time a new user has come, a new thread is created. Thread, you have already know in the Java, the thread is being called, means it's an independent task, you can see. Fifth step is start the simulation. Now I have to execute this task directly because we have very short time. Now see, the simulation is paused for 5 seconds. Okay, after that you can see the results are coming. Okay, so now the starting time and the finish time is printed, and for that, the each time the cloudlet is assigned to the data center broker. The data center broker will assign the task to the data center, and the data center will assign these to the virtual machines. Okay, so this is our seventh example. So is there any doubt? Is there any doubt? If you have any question, you can ask. If you have any question, you can ask. Okay.
If anybody is having any question, they can put up in chat box. We will convey message.
Yes, now I'm moving to the last example of this session. This is in CloudSIM example number 8. Now, see, every time we are changing the values and we are getting the results, is there any importance to execute these tasks? Means, is it important to learn these values? So now I'm going to the another thing. See, yes, see, these are the policies we have made in the cloud sim. This is already in the cloud sim. Okay, we have changed these policies according to the how we want to create, how this simulator will behave in the future task. So we have changed these files according to schemes. Like every time a new policy has came, you can change this in the VM allocation policy. Okay, now see here, only methods are there only, but we have to change the scheme. Now this code is written by us because to change the VM allocation policy, because how you are allocating the VMs is very important in the cloud sim environment, because each time if VM is already been there, you can directly assign the task. But if VM is busy, how will you distribute the task so that there is no any lost time is there? But because every time a task is coming, the virtual machine will block the task because it is already in the execution process. So we have changed this allocation policies. Now coming back to the cloud sim example number 8, here the same, uh, we have used this code is different from the previous code. So we have here used number of CPUs are 1 and the VM name is Zen. So the allocation scheme is different. So for that we have used ID shift plus I. Okay, we have changed these attributes values. You can see these attributes are changed from the previous example. Here ID shift plus I, user ID, MIPS, P is number, and all these values are changed. Okay, now these values are assigned to the virtual machine, and the virtual machine will be uh, uh, will take the task and execute it on the cloud, and these cloud values are printed in the last. Okay, now see the static methods. This is same. This is same. Number of users are two. There are two data centers, and the VM list is different. See, in the fourth step, we have created 5 virtual machines. Okay, we have created 5 virtual machines, and 10 cloudlets are there. So this is important. This is important because we are scaling the cloudlets, because the number of tasks is increasing every time a new user has came, and the number of cloudlets are increased. Now these cloudlets will be executed on the virtual machine, and so there will be multiple virtual machines could be there, maybe 5, maybe 10. So according to the environment, you can see there are, I am taking here the 5 virtual machines are there. Okay, I'm taking, if I take 10 virtual machine, you can change this code, save this code, and then run this again. Okay, the result is different. If I run this code, you can see the results. Okay, so finish time is 320.1 milliseconds for the cloudlet 051. These are the IDs of the cloud, and these are assigned to the data center 3, and the execution time is 320.1 milliseconds. I am taking the time in milliseconds, okay, because second is very large value. The execution time is very minute. This means the variation is very minute. You can check this in the simulator. Okay, so after that, uh, you can see 520.1. So around, see, the variation is very minute. So it is not telling. Means you can take these values in milliseconds. You can calculate these values in a milliseconds, because I have taken these values in the milliseconds in our virtual environment. Okay, so this is the whole code, because it will take so much time to execute each one of, because there are so many files in this. Okay, you can, because here I have taken deadline cloudlet. This is the new file I have made in this cloud sim environment, and this is hard drive storage. These values are changed in the cloud sim environment. This is in host.java. It is different from the previous cloud sim, because in the new cloud sim 7.0, the values are same, but here, according to the virtual environment, you have to change the simulator values. Okay, and the code is different. Okay, so this is in log file. Okay, so every time you have to change these files. There are so many files in this. Okay, whenever a new thing is came, you have to change these values now. Okay, so these are the Jython codes. So Python plus Java, it will generate a Jython code. Okay, so I have executed Jython code in this. Okay, so it in the next, we will execute, surely we will execute this Jython code, because no one understands Jython directly. So we have written this code in the simulation environment. So it's like an add-on feature to the Cloud Sim environment, because in the Cloud Sim, the Jython code is not there. So we have implemented Jython code in this. So if you have any doubt, you can ask me. If you have any doubt, you can ask. So we can conclude. Yes. Is there any doubt?
If anybody is having any question, they can put up in chat box.
Yes. Now we have to conclude this session. So in the last, I have to share some slides. Yes. Is there any doubt, you can ask me? Is there any doubt, you can ask me?
Sir,
Yes.
people are asking for if you can share the code, sir.
Yes, I will share. I will share the code. If you want, I will share these codes to you. And because these are the changed, because I have changed according to my environment. You can change these codes according to your own values and own policies. So I have to stop this session now. If you have any doubt, you can ask me. Yes. If you have any doubt, you can ask.
Sir, there is a question.
Hmm.
It says how to put the imbalance factor in cloud server, no nodes.
Yes. If there are no nodes in the cloud sim environment, means these see this is different part. You can check in this cloud sim environment, and yes, is my screen is visible? Is my screen is visible?
Yes, yes, yes,
Yes.
your screen is
Can
visible.
can you repeat the question again? Can you repeat the question again?
The question says how to put the imbalance factor in cloud server with no nodes.
Okay. This is very important task, because every time a user came to the cloud environment, okay, there will be a load balancing skills are there. Okay, for that you can use a imbalance factor. Imbalance means these load balancing skills. Okay, Load balancing schemes are required whenever off-load balance is there or on-load balance is there. Means whenever there is a load on the cloud, we have to distribute these loads on a virtual machine. Either it will be in a hybrid cloud or it will be in a virtual cloud. These both things are different. Either it will be an on-loading balances or it will be an offloading balance. Okay, so for that you can use this factor. Means you can use. I have used random numbers in the Cloud SIEM environment. You can use this imbalance factor, which is used for to how these tasks will be distributed to the virtual machine. Okay, like I have used data center broker. Okay, in this data center broker, what it will do, it will take the cloud dates and it assign these cloud dates to the data center. Okay, same here, same here. Whenever a load is there on the cloud, like there are 5 to 10 tasks are there. Okay, on the Cloud SIEM environment. Now I have to evenly balance this load on the Cloud SIEM. Now what I will do, I will divide this task, like 5 tasks will be given to the virtual machine 1 and 5 tasks will be given to the virtual machine 2. Okay, so you have to make a virtual machine allocation policy, different virtual machine allocation policy. Okay, here you can see here a VM allocation scheme policy is there. Okay, you can change this code according to your own needs. Okay, here you can take a host for different numbers. Okay, and for that you can use balancing scheme, load balancing scheme is there. Okay, like I have used a FLB. There are so many algorithms are there. I have used different schemes. Every time whenever there is load on the cloud, we have to use a different load balancing schemes. Yes, so yes, if you have any doubt you can ask. Yes, anybody has any doubt?
Any other questions?
Any other questions? Yes. So before concluding this, I have to share some uh, I want to share you some slides which I have prepared. I will provide these slides to you. Okay. uh, I have taken these. Yes, is it visible? Is my screen is visible?
Yes, sir. Yes, sir.
I have made this.
Yes, sir. It is.
Yes. So my motive to prepare these slides is to show you the comparison of Cloud SIEM with other simulation environments. Like these are the ICANN Cloud, Grid SIEM, and SIMGrid. These are different. You can take different Cloud SIEM environments. Okay, but why I have used Cloud SIEM here? Because the focus is highly customizable. Every time I'm changing the allocation policy scheme, every time I'm changing the VM attributes, so it is highly customizable. The energy consumption is very high. You can see the code execution time and the file, because the simulation has around hundreds of files are there. Excellent for the cloud. You can make your own environment in the hybrid. Resources type like CPUs, memory, storage, energy, VM host are there. Full application simulation environment is there, and see, there is a strong support for the Cloud SIEM in the simulator for the simulator purpose. You can either go to the Python, and for the Python you can design your own cloud in the Python also. Okay, but for the desktop purpose, if you want to use a highly customizable environment, because in this you can check if this is the environment, how the cloud will work. Okay, because you cannot directly implement this on the, like, you can use the AWS, you can use for the Cloud SIEM, you can use Microsoft Azure. There are so you can use either Google Cloud is there. You can use, these are the means giants of the cloud simulation. Okay, so you can either go to the Google Cloud here. That is different thing. Okay, here you can implement your own algorithms and check. Now coming to that, for the practical purpose, I'm using this Cloud SIEM environment, and because it's a free and open source, and it's easy for us to understand the things. Okay, now. Okay, so I will share these codes to you, and after, because in the next session also we will go through these practical exercises. Okay, after that I will share the slides and codes with all of you. So if you have any doubt, you can come to session and ask the doubts during the session. Okay, so thank you.
So I think no one is having any doubt. So to wrap up the session, I would like to thank you, Mustaq sir and VCV Rao sir, for taking wonderful session today. For tomorrow, we will meet again at same time. There will be two sessions, 9:30 a.m. in morning and 4 p.m. in evening. So we will be meeting again tomorrow. Thanks.